Junior Cycle Higher Level 2015 sample. Paper 1, question 2. This is a sets question, and it is asking us to sort of look at a group of sets defined by some rules, multiples of 2, multiples of 3, multiples of 5. And they define the universal set as all the numbers from 2 up to 30. Now what you could do is, to help yourself, is you could actually write out what A actually is. Okay, so all multiples of 2, 2, 4, 6, 8, 10, 12, and so on and so on and so on. You might want to write them all out. Same for B, you might actually want to write them out. So 3, 6, 9, 12, 15, and so on and so on and so on, all the way up to 30. And likewise C is 5, 10, 15, 20, 25, 30. Must actually write them all out, easy enough. Now, this question is about the complement, so you need to know the complement, represented by that little dash that you see there. So A and B and C complement. So what this means is what is outside of the union. If you were to think of the union in the Venn diagram scenario, we're talking about all of everything and anything that's in any of the sets A, B and C. So if you want the complement, we're talking about outside of that. So in this case, it's around the outside. So what's not in A or B or C? What's in none of them? That's basically what it's asking of you. So all the numbers from 2 up to 30, it's a case of just identifying which numbers aren't in any of them. So which numbers aren't even, aren't multiples of 3s, and aren't multiples of 5. To a certain extent, just a case of going through all the numbers. Start with 2, then 3, then 4, then 5, and work your way through. So, starting with 2, 2 is in A. So we can straight away ignore that. 3 is in B. 4 is in A, 5 is in C, 6 is in B, 7 and also A. 7 now is 7. 7 is not in any of them, so 7 will be one of our values. So you can start listing them. And once we've worked out how many there are, then we can start working out what they are. We can then say, right, we know how many of them there actually are. So you can carry on doing that. And there's all the values: 7, 11, 13, 17, 19, 23, 29, and that's 7 values in total. So the cardinal number, which is what that sign means, the cardinal number of this complement set is 7, because there are 7 elements in this subset. That's a straightforward process. The other thing you could have done is actually just draw out the Venn diagram. So you have a visual representation of what's going on, and then you just see what numbers weren't inside the circles, they had to be put outside the circles. And that's the representation you'd have. It's a bit scratchily done, but that gives you the idea. And then I can say to myself, right, well, the elements that I want, all the ones that weren't inside the circles, it's these ones here. There are 7 of them, therefore my answer is 7. Moving on to part B, you're asked how many divisors does each of the numbers in this subset actually have. So these numbers 7, 11, 13, 17, 19, 23, 29, how many divisors actually are there? Well, to a certain extent we should realise what sort of numbers they are. You should realise they are prime numbers, and if they're prime numbers, and that in itself is part of the sort of the answer, that you can realise that's what they are. Therefore, prime numbers, it's always going to be 2 divisors. Okay? The divisors that are itself and 1. And lastly, what name is given to the numbers that have exactly this many divisors? Well, you've already realised, we've already discussed it, it's prime numbers. Okay? And as I said to you, you can actually show that 7 is equal to 7 times 1, and 11 is equal to 11 times 1, and so on and so forth if you wanted to. But the key idea is prime numbers, basic premise.